Download this code from codegive.com, link in the description below. Raptor Flowchart Tutorial, Input Validation with Examples. This tutorial will guide you through the process of implementing input validation using Raptor flowcharts. Input validation is a critical aspect of software development, ensuring that the data entered by users or received from other sources is in the correct format, within acceptable ranges, and adheres to specific rules. This prevents errors, security vulnerabilities, and program crashes. What is input validation? Input validation is the process of checking user-supplied data to ensure it meets predefined criteria. It acts as a first line of defense against incorrect data preventing program crashes caused by unexpected data types or formats. Security vulnerabilities blocking malicious code injection or exploits that could compromise system security. Logic errors ensuring that data used in calculations or decision-making is reasonable and valid, avoiding illogical results. Data integrity maintaining the consistency and accuracy of data stored in databases or files. 2. Why use Raptor for input validation? Raptor provides a visual, intuitive environment for designing and testing algorithms. Using Raptor for input validation allows you to visualize the logic easily see the flow of validation checks, making it easier to understand and debug. Experiment with conditions quickly modify validation rules and observe the effects. Learn programming concepts gain a fundamental understanding of conditional statements, loops, and variables, which are essential for input validation in any programming language. Document the process the flowchart serves as clear documentation of the validation rules. 3. Key Raptor components for input validation input symbol used to prompt the user for input and store the entered value in a variable. Assignment symbol used to initialize variables or perform calculations needed for validation. Decision symbol the core of input validation. It evaluates conditions and directs the flow based on whether the condition is true or false. Output symbol used to display error messages to the user or confirm valid input. Loop symbol, while or do until used to repeatedly prompt the user for input until valid data is entered. 4. Basic input validation techniques and Raptor implementation Let's explore some common input validation scenarios and how to implement them in Raptor. 1. Checking for empty input goal ensure the user provides some input, preventing the program from processing an empty string or null value. Raptor flowchart explanation One input prompts the user to enter their name and stores the input in the name variable. 2. Decision checks if the name variable is equal to an empty string. 3. True branch if the name is empty, an error message is displayed, and the program prompts the user for input again. This creates a loop until a non-empty name is entered. 4. False branch if the name is not empty, a welcome message is displayed along with the name, and the program ends. 2. Checking for numeric input, integer. Goal ensure the user enters a valid integer number. We need to handle potential non-numeric input that could cause an error. Raptor doesn't have a built-in isInteger function, so we'll rely on error handling and string conversion tricks. Raptor flowchart explanation One input the user enters the number as a string and stores it in number str. 2. Initialization is valid is set to true initially, assuming the input is valid. I is the loop counter, starting at 0. 3 While loop asterisk the loop continues as long as I is less than the length of the string, number str, and is valid is true. 4 Character extraction asterisk inside the loop, substring, number str, I, 1, extracts the character at index I and assigns it to char. 5-digit check asterisk the decision symbol checks if the character char is not a digit, i.e., char 0 or char 9. 6 Invalid input asterisk if a non-digit character is found, is valid is set to false, breaking the loop. 7 Increment counter asterisk if the character is a digit, the loop counter I is incremented to check the next character. 8 Label asterisk a label is added to signify when the while loop condition evaluates to false. 9 Final check asterisk after the loop, another decision symbol checks the value of is valid. If it's still true, the input is a valid integer. If is valid is false, an error message is displayed, and the user is prompted for input again, restarting the validation process. 10 Conversion to number asterisk if the integer validation succeeds, string underscore to underscore number, number str, converts the valid number str string to a numeric value, assigning it to the number variable. This is important for performing mathematical operations later. Important notes for numeric input in Raptor asterisk. Asterisk error handling asterisk the above approach avoids errors in Raptor. Raptor doesn't have robust built-in error handling, a try-catch block approach is not directly implementable in Raptor. Rely on string processing for input validation. 3. Checking for input within a range asterisk asterisk. Asterisk goal asterisk ensure the user enters a number within a specified range, example between 1 and 100. Asterisk Raptor flowchart asterisk. Asterisk explanation asterisk. 1 Input, string prompts the user for a number as string. 2 Integer string validation asterisk uses the same integer string validation logic as described in example 2, loops through the string and checks each character. 3 Convert to number, if valid string if the string is a valid integer, converts to a number using string underscore to underscore number, number str, and stores in number. 4 Range check asterisk checks if the number is within the desired range, 1 to 100. The condition number equals 1 and number equals 100 ensures it's both greater than or equal to 1 and less than or equal to 100. 5 Output asterisk displays appropriate messages based on whether the number is within the range or not. If not within the range, the user is reprompted for input and the validation repeats. 4. Checking for specific string format, email example. Asterisk goal asterisk validate if a string entered by the user matches a basic email format, example something at domain.com. This is a simplified example, robust email validation is complex. Asterisk Raptor flowchart asterisk. Asterisk explanation asterisk. 1 Input asterisk prompts the user for their email address and stores it in the email variable. 2 Finds symbols asterisk. Asterisk index underscore of, email, at, finds the position of the at symbol in the email string. If it's not found, it returns 0. This is assigned to at symbol POS. Asterisk index underscore of, email, dot. Finds the position of the dot symbol in the email string. This is assigned to dot symbol POS. 3 Validation condition asterisk the decision symbol checks several conditions. Asterisk at symbol POS 0, ensures the at symbol exists and is not the first character. Asterisk dot symbol POS at symbol POS plus 1, ensures the dot symbol exists and is after the at symbol, with at least one character in between, example a at b.com. The plus 1 prevents a at.com. Asterisk dot symbol POS length underscore of, email, 1, ensures the dot symbol is not the last character. The 1 prevents A at B. 4 output asterisk displays valid email format if all conditions are met, otherwise, displays an error message and reprompts for input. V. Advanced input validation considerations asterisk asterisk. Asterisk regular expressions asterisk for more complex string validation, regular expressions are a powerful tool. Unfortunately, Raptor doesn't have direct support for regular expressions. You would need to use a programming language with regular expression support to implement very complex pattern matching. Asterisk data type validation asterisk Raptor attempts to implicitly convert strings to numbers if necessary. You can use error handling techniques, as shown in the integer example, to validate numeric input. Asterisk custom validation rules asterisk you can create custom validation rules based on specific business logic. For example, you might need to check if a username is unique or if a password meets certain complexity requirements. These rules would be implemented using additional decision symbols and logic. Asterisk user experience asterisk provide clear and helpful error messages to guide the user in entering valid data. Avoid generic error messages like invalid input. Be specific about what is wrong and how to correct it. 6. Complete example, validating user age. This example combines several validation techniques. 1 non-empty input. 2 numeric input. 3 range check. Explanation asterisk. 1 input asterisk prompts the user to enter their age, as a string. 2 empty check asterisk checks if the input is empty. If so, displays an error and reprompts. 3 integer string validation asterisk uses a loop to check if the input string contains only digits. 4 conversion to number, if valid if the string contains only digits, it's converted to a numeric value. 5 range check asterisk checks if the age is within a reasonable range, 0 to 120. 6 output asterisk displays either a success message or an error message and reprompts for input if the validation fails at any stage. 7. Conclusion. Input validation is an essential part of writing robust and secure programs. Raptor provides a valuable visual tool for understanding and designing input validation logic. By using input, decision, and loop symbols effectively, you can create flowcharts that ensure your program receives and processes valid data. Remember to always provide clear error messages to guide the user and to consider all possible input scenarios when designing your validation rules. While Raptor is excellent for learning and prototyping, for production systems, a programming language with more robust error handling and data type validation capabilities is generally preferred. However, the logical concepts learned in Raptor are directly transferable to those languages.